Hello students, in this video we will see the next example of finding the resultant of the given force system. The example that we have wherein a bent pipe is acted upon by three forces F1, F2 and F3, where F1 and F2 acts parallel to the coordinate axis. That is, F1 is parallel to the x-axis over here towards the positive side, and F2 is parallel to z-axis but on the negative side. Now I need to replace these forces by a single force and couple at origin O, that is at this point. So what I need to do in this case is I need to first find out the resultant, and then I need to find out the moment of these forces. To find out the resultant, we have seen that resultant is nothing but the summation of the force vectors that I'm having. Now, in this example, it is easier for us to find out the force vector F1 and F2 because F1 is acting along the x-axis, it is parallel to the x-axis and towards the positive side. So the force vector will be 20 I cap. Whereas F2, since it is acting parallel to the z-axis but on the negative side, it will be 10 k cap minus 10 k cap. All I need to do is find the force vector for F3. But to do that, I need to first find out the coordinate of point D and C. Point D lies on the x-axis. So y coordinate and z coordinate will be 0. So the coordinates will be 0.2, 0 and 0. Whereas for point C, it is lying somewhere in the space. So I need to find out the coordinates. It is on the positive side of x-axis, so that will be 0.2. It is on the negative side of the y-axis, that means it is going down, and y-axis is over here, so this will be this distance, that is 0.3 but negative. Whereas the z distance, that is this distance, is given to me as 0.3 meters, so this will be 0.3 positive. Now I have got the coordinates of the point, I have got the coordinates through which the force F3 is passing. So I can easily find the force vector F3. F1, we know that it is 20I and F2 is minus 10K. F3 will be the magnitude that is given to us as 20 dot product with unit vector along DC. So this will be this is how we can find the resultant vector for the three forces. The next step will be to find out the moment of these three forces about origin. So for that, we need to find out the net moment about O, that is a moment vector, and that will be moment about O for force F1 plus moment about O for force F2, and similarly for force F3. Moment about O for force F1. that is this, will be nothing but the cross product of the position vector and the force vector. So the cross product, that is, the position vector will be along OA. So I can write it as OA cross product force vector F1. Similarly, position vector for F2 will be OB plus position vector along OD F3. Here it should be cross product F2. So now I'll just write down the cross products over here to get the net moment about O. The force along, the force vector F1 is nothing but 20I. I don't have the J and the K components, so I won't write that. To find the position vector along OA, I have it over here, OA. So that will be nothing but the coordinates of A minus the coordinates of O. The coordinates of A, I'll write it over here. Since the point lies on the z-axis, so x coordinate and the y coordinate will be 0 and the z will be 0.3. So it will be nothing but 0, 0 and 0.3 plus the cross product for the second force. Second force, that is F2, is parallel to z-axis, and we know that force vector is nothing but 10k minus 10k. So I'll write over here minus 10. I component and j component will be 0. The position vector will be, I've written over here as OB. So for that, I need to find out the position vector OB. So I need to find out the coordinates of point B in this case. So the point B coordinates will be, point B lies in the xz plane. So y coordinate will be 0. X is 0.2. Z is 0.3. So 0.2, 0 and 0.3. So I'll get it as 0.2, 0 and 0.3 plus the next will be the force vector for F3, that is over here, this much part. So I'm not having the I component, J and K component are same, so I'll write over here now the position vector along, I've written it as OD. So it is along OD, that will be nothing but 0.2, 0 and 0. So I'll write over here it as 0.2, 0, 0. Now I need to just calculate this determinant values and find the net moment. The moment vector for the three forces is coming out as this value with the unit as kilonewton meter. So this is how we can calculate the moment vector for the given force system about origin. This was the moment about origin for the given forces. I hope you have understood this example. Thank you.